It's no secret that the B-52 is an old jet, and with that comes a lot of problems of keeping it at flying. Here's an inside look at how maintenance crews do just that. It's a plane so old that 4 generations of American pilots have flown it. From pulling nuclear alert in the Cold War, to arc-light strikes in Vietnam, to precision cruise missile attacks in Desert Storm, the B-52 has done it all.
In the long history of military aviation, some aircraft transcend their role as mere machines, becoming icons of doctrine, deterrence, and adaptability. The B-52 Stratofortress is chief among them, a symbol of sustained American air power for over 70 years. First leaving the Boeing assembly line during the tense early days of the Cold War, this bomber has become emblematic of evolving strategies and enduring global reach. Since taking flight on April 15, 1952, the B-52 has established its place in culture and military tradition, from operational air bases to depictions in media. Its durability, consistent modernizations, and proven capability have ensured it persists in a world where few technologies remain unchanged for decades. As the 70th anniversary of its first flight draws near in 2025, the Pentagon has set in motion the most consequential modernization in the B-52's remarkable service. From a comprehensive re-engining program to advances in radar, avionics, displays, and nuclear weapons capability, these upgrades mark not just technological progress, but a visible commitment to maintaining the U.S. strategic edge amid an uncertain future. However, modernization never arrives without challenges. Delays in radar development, increased costs, and an environment shaped by rapid technological progress and rival missile threats demand both foresight and resilience. Yet the B-52 continues, its airframes aged but its mission constantly renewed. With the Commercial Engine Replacement Program, CERP, underway, and the introduction of the Long-Range Standoff Missile, the story of the B-52's future is shaped by adaptation, endurance, and the unpredictable demands of global security. The real question is no longer why the B-52 remains relevant, but how its upgrade is set to influence the landscape of deterrence and conflict for decades to come. Forged for the future, the engine at the core. Understanding the magnitude of the B-52's upgrade begins with its most fundamental system, its engines. The B-52's original Pratt and Whitney TF-33 engines, while reliable over thousands of missions, have grown increasingly difficult and costly to maintain. Diminished efficiency, increased risk of failure, and part scarcity have all threatened the bomber's operational viability, not due to combat losses, but to the pressures of time and obsolescence. Each overhaul now demands more work and ingenuity, with spare parts sometimes sourced from dwindling stockpiles or custom fabrication. The maintenance burden grows, risking readiness at a time of great power competition. The Commercial Engine Replacement Program introduces the Rolls-Royce F130 engine, designed to replace the aging TF-33s across the B-52 fleet. The F-130 isn't simply a new part, it is a major technological upgrade engineered to improve reliability, efficiency, and maintainability well into the future. Features of the F-130 engine include advanced digital monitoring for predictive maintenance, sensors transmitting performance data to ground crews, and improved fuel efficiency. Early data and projections suggest significant reductions in unscheduled maintenance and operational cost, coupled with increases in mission readiness. The benefits extend directly to operational capability, improved range due to lower fuel consumption, enhanced ability to operate from more distant bases, and reductions in logistical complexity, particularly those associated with in-flight refueling. As the U.S. military pivots attention toward the vast distances of the Pacific, these attributes acquire strategic significance. Integrating new engines into 6-decade-old airframes presents real engineering and operational hurdles. The Air Force plans to modernize all 76 bombers in its fleet by 2036, a project reflecting the scope and complexity of such work. Electrical, hydraulic, and other crucial systems must be integrated and adapted. Training must occur for pilots and maintenance crews, marking an institutional refresh not unlike the original transition from piston to jet engines generations ago. In the years to come, successful engine replacement will have a force-multiplying effect. not only preserving the B-52's mission capability, but transforming it into a modernized asset able to meet contemporary military requirements. Eyes in the sky, radar, and avionics modernization. An upgraded engine moves the bomber, but its effectiveness depends on what it can see and process. That is the purpose of the B-52's extensive radar and avionics overhaul. The original radars, functional for their era, lack the ability to match modern threats, especially amid the proliferation of stealthy aircraft, advanced surface-to-air missiles, and aggressive electronic warfare. The U.S. Air Force has committed to fitting the B-52 with a new Active Electronically Scanned Array (AESA) radar system. This upgrade is foundational. The AESA radar offers expanded detection ranges, multi-target tracking, and superior resistance to electronic countermeasures. Equally vital, the system can perform simultaneously in multiple modes: air, ground, and sea surveillance, allowing crews to interpret and respond to complex operational environments in real time. Delays, however, have marked this effort. The upgraded radar is now not expected to be operational on B-52 bombers until as late as 2030, a 3-year shift from initial targets. These postponements have real-world implications as potential adversaries continue to invest in capabilities, such as advanced aircraft and missile systems, aimed at denying the U.S. unrestricted access to contested regions. Beyond radar, the B-52's avionics are being streamlined and digitized. New cockpit displays, including touchscreens and integrated glass panels, will replace legacy analog dials. These upgrades connect the bomber seamlessly to the broader force, better supporting data sharing under joint operational concepts. Enhanced displays, computational power, and digital links will allow bomber crews to respond faster to missions and threats, while network integration supports contemporary doctrines centering on distributed and multi-domain operations. The modernization further includes machine learning-aided subsystems to support threat recognition and mission planning, reinforcing the B-52's role as a real-time contributor within a sophisticated data-centric force. Delays and cost challenges aside, these efforts collectively support the aircraft's continued centrality in U.S. strategy, ensuring the B-52's ability to detect, track, and engage targets under modern electronic warfare conditions is not just a technical milestone, but a requirement for credible deterrence. Weapons of the future, the long-range standoff cruise missile. No transformation of the B-52 would be complete without advancing its onboard weapons systems. Central to this is the long-range standoff, LRSO missile, a next-generation, nuclear-capable cruise missile developed specifically to sustain the credible reach of the U.S. bomber force in an era of sophisticated enemy air defenses. Designed to survive and evade modern integrated air defense systems, the LRSO delivers the B-52 a standoff nuclear strike option. Its expected range, exceeding that of its predecessor, the AGM-86B, enables the B-52 to launch attacks from distances well outside the engagement zone of most surface-to-air missiles. The LRSO's precision guidance and in-flight retargeting features aim to complicate adversary defenses and ensure that even legacy aircraft like the B-52 remain a persistent, credible part of the U.S. strategic triad. This capacity, integrated with upgraded radar and avionics, moves the B-52 beyond its Cold War role. With both conventional and nuclear options at range, the aircraft becomes a flexible tool for modern deterrence, aligning with contemporary U.S. strategies calling for adaptable and resilient long-range strike capability. These enhancements to the B-52's weaponry have important signaling effects for allies and adversaries alike. In Asia and Europe, continued investment in the platform underscores U.S. commitments and the durability of its security guarantees. For potential adversaries, the pairing of legacy bombers with advanced standoff weapons complicates planning and reinforces the credibility of American extended deterrence. The LRSO's ultimate success depends on its seamless integration with the broader suite of planned B-52 upgrades: modern engines for range and reliability, advanced radar for targeting, and digital avionics for command and control. Each element reinforces the others, giving the B-52 renewed purpose as a platform for both reassurance and deterrence. Modernizing the essentials. wheels, brakes, and ground systems. Often overshadowed by more high-profile upgrades, improvements to the B-52's wheels, brakes, and undercarriage are vital to its continued operational effectiveness. The original design of these systems reflected the requirements of an earlier era: long, unconstrained runways and a relatively predictable operational tempo. In modern contexts, bombers must frequently operate from crowded, sometimes austere bases and adapt rapidly to increased deployment cycles. The upgraded wheels and brakes are engineered for greater durability and rapid turnaround under the conditions of contemporary air operations. Enhanced thermal characteristics allow for safer, faster landings and departures, reducing the time needed between sorties and improving the overall tempo of bomber operations. Improved reliability ensures that the B-52s can safely operate from forward or temporary bases, an increasingly important consideration given the risk of missile strikes on major installations. These changes, while technical, add resilience to bomber operations. Every reduction in maintenance downtime or improvement in sortie rate is an asset in high-intensity conflict or crisis scenarios. Operational flexibility, having the ability to take off, land, and rearm at bases across the globe, reinforces the B-52's enduring role as a rapid response asset. The Pacific Theater and the strategic signal. The significance of these upgrades is perhaps most tangible in the Indo-Pacific region, where the B-52 serves as both a deterrent and a symbol of ongoing U.S. commitment. Regular B-52 deployments and joint exercises alongside allies send clear messages, not only to U.S. partners, but to regional competitors as well. China's investment in anti-ship and long-range missile capabilities, designed in part to complicate American military intervention, has made power projection more demanding. Enabling B-52s to launch standoff missiles from outside these contested zones sustains their role as a credible threat. The upgrades help ensure that, in the event of crisis, B-52 bombers operating from platforms as distant as Guam or Alaska can participate in conventional and nuclear response options, supporting U.S. deterrence without undue risk. The delay in new radar integration, however, represents a challenge. Until the AESA radar is operational, B-52s flying these missions will do so with systems that are increasingly challenged by modern threats. Such gaps are closely monitored by policymakers and planners throughout the region, where perceptions of U.S. resolve and capability are shaped by both technical upgrades and operational presence. In this context, modernization is not only about battlefield performance, it is a means for the United States to assure allies and deter potential adversaries through visible, credible demonstrations of ongoing capability and commitment. Enduring relevance, adaptation as strategy. The Pentagon's decision to invest in B-52 modernization is not driven by nostalgia, but by careful strategic calculation. Developing and fielding entirely new bombers presents higher costs and longer timelines. Upgrading proven platforms leverages existing strengths while bridging capability requirements in the near and medium term. Every improvement to the B-52 is an investment in layered deterrence, combining the aircraft's recognized profile with new capabilities concealed within. Strategic modernization decisions, reflected in budgeting priorities and technical planning, are intended to ensure that U.S. global strike forces remain effective, resilient, and visible to both allies and rivals. The current round of upgrades extends not only the mechanical life of the platform, but also its operational and doctrinal relevance. The B-52, originally fielded for Cold War missions, is being thoroughly adapted for today's distributed, networked, and technologically complex battlefield. This approach reflects a larger philosophy that sustainability, innovation, and adaptability are integral to modern military power. Through methodical modernization, the B-52 remains a visible marker of American commitment and a continuing asset in an era defined by technological competition. The stakes of persistence. As the next generation of aircrews trains on upgraded simulation systems for the modernized B-52, and as each aircraft emerges from overhaul equipped with F130 engines and new electronics, the strategic calculus is quietly shifting. These upgrades don't simply extend service life. They expand the scenarios under which the B-52 can credibly participate in both deterrence and, if necessary, combat. Each aircraft that returns to operational status following modernization demonstrates American resolve to maintain credible strike capability even as the nature of war and competition evolves. The journey toward a fully modernized B-52 fleet is not without risks. Cost overruns, technical delays, and evolving adversary capabilities reflect the persistent challenge of sustaining military advantage. Yet with each completed upgrade, with every improvement to range, survivability, and operational tempo, the U.S. Air Force ensures that its fleet remains woven into the fabric of global security. In transitioning from an instrument of Cold War brinkmanship to a flexible node in 21st century deterrence, the B-52 embodies the principle that adaptability and continuous improvement are as critical to national security as any new technology or weapon system. A platform renewed. For 70 years, the B-52 Stratofortress has exemplified the value of adaptation in defense planning. The Pentagon's current upgrade program combines technical rigor with strategic foresight, reinforcing a powerful message: enduring platforms can and will evolve to meet new threats and challenges. The next time a B-52 rises into the sky, propelled by new engines, guided by advanced radar, and loaded with modern standoff weaponry, it delivers not just payload, but the cumulative weight of sustained commitment. It bridges eras in American air power, linking the lessons of the past with the demands of today and the uncertainties of tomorrow. Through careful modernization, the B-52 affirms that resilience, understood as the ability to adapt and persevere, is a decisive asset. In both peace and crisis, that resilience serves as a credible guarantee that American deterrence rests on more than past glory. It is continually renewed through thoughtful innovation and sustained investment. For 7 decades, the B-52 Stratofortress has proven that with vision and continuous effort, legacy systems can achieve renewed impact. The Pentagon's ongoing modernization is more than an engineering program. It is a declaration that innovation and commitment remain at the heart of U.S. strategy. Each upgraded B-52 embodies a dual legacy, honoring its past while providing for a future in which it continues to play a vital role in safeguarding American interests around the globe.